Hi, hello everyone. Welcome to our channel Physics for AP. So I'm drinking a warm water, so as it is good at this time as the corona effect. So drinking a warm water makes you feel increase your immunity power over here. So let's have a small concept on this here. So I have a glass of water, and when I dip this pencil into here, you might have seen there is a difference between this pencil and the image of the pencil which you see inside. Can you tell me what is the name of this phenomena? So it's called refraction. So refraction is the property of a light which bends when it moves from one medium to another medium. So here we have the air as a medium, and here we have a water as another medium. So when the light travels from the rarer medium to denser medium, it bends. So that is why you can see the difference between. So here we have a pencil of one ray, and the image of the pencil which you can see is in the other place. It's been displaced. That is what the bending of light. But if you make it exactly perpendicular, that is exactly at 90 degrees, so you can see there is no bending of light over here. So there is no bending of the pencil. But now you can see the bending of pencil right now. But exactly at 90 degrees there is no bending. That means the phenomena which bends from one medium to another medium, that we will be discussing later. So this is called refraction. But refraction doesn't occur at exactly 0 degrees, that is which is perpendicular, which is exactly the normal. If we take the normal, from the normal if you make it as the 0 degrees like this, then you can see that there is no refraction over here. So let us learn about more terms like the refractive index, what is the velocity of light, whether it increases or decreases, so which is the denser medium, which is the rarer medium, that will be going to explain. So what are we waiting for? So let's move on to our channel Physics for AP. So let's discuss about the refraction of light. So it is a phenomena of the bending of light at a surface separating the two mediums. So as if you have seen the glass which is separating the two mediums, that is one is the air and one is the water. So when light travels from one medium to another medium, the light bends. So that phenomenon is called as the refraction of light. So let us see what are the topics which we are going to cover in this refraction of light. So in this refraction of light, we'll be dividing into two parts. One is about the plane surface and another one is of the curved surface. So let us see what we are learning in the plane surface. So in plane surface, we'll be learning about the denser medium and the rarer medium. We'll be learning about the refractive index. So in that refractive index, we'll be learning about absolute refractive index and relative refractive index. Then we will be learning about the Snell's law, the verification of the Snell's law and its applications. And these applications will be learning about the total internal reflection and the critical angle over here. And next we will discuss about the curved surface. In that curved surface, mainly we will discuss about the lenses. So what are the lenses, what are the different types of lenses. We will discuss about the convex and concave lenses and its respective image formation of the ray diagrams and the applications. And on one side we will discuss about the lens formula and the numericals, how to solve the numericals, and also which we have another one which is the lens maker formula, to make a lens what we need, so the lens maker formula. And on the other side we will be discussing about the structure of eye and the defects of eye, so that is the myopia, hypermetropia, presbyopia. And lastly we will discuss about the two main applications of refraction, that is the subpart which is the dispersion and the scattering. So how does the rainbow forms, why does the sky appears to be blue in color, so those type of reasons we'll be looking into dispersion and the scattering over here. So let's move on to our topic about, we'll discuss about the plane surface. In that we'll discuss about the denser medium, rarer medium and the refractive indexes. So let us see, here we have taken it. So consider this as a water. So this is a water. Now the whole content is present in the water. As this is air and this is water. Now which one is considered to be the rarer medium and which one is considered to be the denser medium, that we need to discuss now here. So which is rarer medium and which is denser medium, that depends upon the density of the material. If the density of the material, so density, as we know the formula, density is equals to mass by volume. So the density is equals to mass by volume. So based upon this calculation, if we have the density more when compared to another, then that is said to be called as a denser medium. Now for example, if you take air and water, so when compared these two, the density is more when compared to the density of water is more when compared to air. So as the density of water is more when compared to air, now this is said to be called as the denser medium, and the air is said to be called as the rarer medium. It is said to be called as the rarer medium. Okay, now let's see what happens when a light travels from one medium to another medium. So we have two mediums, the rarer medium, denser medium, that is air and water. So let us see what happens when a light travels from one medium to another. Now suppose we have a light ray which is passing on the surface, which is passing on the surface. Now here the m dash are the separating medium, that is, it is the separating medium between the rarer medium and the denser medium. It is the separating surface, and here n is the normal which is perpendicular to the surface, which is making an angle of 90 degrees. And now here a light ray is passing through the medium and it is incident upon the surface over here. Now here the angle between the light ray, that is the incident ray, which we call this as the incident ray, and the normal is called as the angle of incidence I. So this is the angle of incidence I, and this is the incident ray. Now actually, as the light ray travels in a straight line, we already have seen in the reflection part that the light travels in a straight line. Now the path of the ray should be in a straight line like this, but due to the separation of medium, as the medium is denser when compared to the rarer, so the light ray bends. That property, what we call it as refraction over here. So that is what we call the refraction. So when it bends from rarer medium to denser medium, the light ray bend towards the normal. That means as the light ray should move straight like this in this part, but due to the presence of denser medium, the denser medium bends towards the normal. So the light ray bend towards the normal like this. So this is the refracted ray. We call this as the refracted ray. So we call it as the refracted ray, and this we call it as the incident ray. So the incident ray, and here the angle is called as the angle of incidence, and here the angle, that is the angle between the refracted ray and the normal, is R, which is called the angle of refraction. Angle of refraction. Now this is the case in which the light passes from the rarer medium to the denser medium. Now what happens, the conditions over here. The first condition, when the light travels from rarer to denser medium, so rarer medium to denser medium, so the angle of incidence is greater than angle of refraction. The angle of incidence is greater than angle of refraction. Is it clear? That is, when light travels from rarer to denser, the angle of incidence is greater to angle of reflection. Next, number 2, let us see the velocities of light. Does it vary, or does it be same? So let us consider this velocity of light as v1, and here the velocity of light as v2. Now which one is greater and which one is lesser, or whether both are equal? So if the light travels in a straight line, then there is no change in velocity, but when there is a change in its direction, then definitely there will be a change in its velocity also. Why? Because already we know that velocity is a vector quantity which has a magnitude and direction. When its direction changes, automatically its magnitude also changes over here. So as the direction path of the light has been changed over here, so the velocity of the light also changes. Now which one will be more and which one will be less is the light which is present in the rarer medium, that is the velocity will be greater when compared to the velocity of light in the denser medium. Is it clear? Now the velocity of light in the rarer medium is greater than the velocity of light in the denser medium, that is V1 is greater than V2. And we have another case, that is number 3, that is the wavelength lambda, that is the wavelength of the light lambda 1 lambda 2, that is the wavelength of the light. So the wavelength of the light is also greater when compared to the denser medium wavelength, that is the wavelength of the light which is greater in the first medium and less in the second medium. As we know that velocity is equals to lambda into frequency. As velocity and lambda both are directly proportional here, so if velocity increases, wavelength also increases over here. If the velocity decreases, wavelength also decreases. So as the velocity is more when compared to the second medium, so here the wavelength of the first medium is also more when compared to the second medium. Now fourth, what happened to the frequency? So the frequency in the refraction is constant, that means it doesn't changes. So the refraction in the due to the light, the frequency of the light during refraction doesn't changes, only the velocity of light changes, the wavelength changes, but the frequency doesn't change. So these are the 4 quantities that we need to remember when the light travels from rarer medium to denser medium. So that is the angle of incidence is greater, the velocity of first medium is greater, the wavelength of the first medium is greater, and the frequency of the first and the second, the frequency of the light is constant. That means there is no change in this. Now let us move on to the second, that is which is traveling from denser to rarer. Let us see that the first medium here we have the denser medium, and let us consider this as the rarer medium. So denser medium, so let us consider this rarer medium as water or air, and the denser medium we consider it as a glass. So I'm taking this as a glass. So this is the glass, and let us consider the rarer medium as air or water, which can when compared to the glass, air and water are rarer medium. So let us take this as air or water, that's our wish. Now what happens when a light travels from the denser medium to the rarer medium? So when the light travels from denser medium to rarer medium, actually the ray should pass in a straight ray like this. So it should pass in a straight line. But as there is a separation of medium, as it is passing from denser medium to rarer medium, so there is a bending of light ray. So that bending of light ray as will be traveled away from the normal. So this is the point of incidence, and it bends away from the normal. So as we know, this is the incident ray and this is the refracted ray. The angle between the incident ray and the normal is the angle of incidence I, and the angle between the normal and the refracted ray is the angle R, over here. So here the light is traveling from denser medium to rarer medium, it bends away from the normal. Now let us see the conditions over here. So denser medium to rarer medium. Let us see the first case. So when light travels from denser medium to rarer medium. Now as if you observe the angle between these two, which is the greater one over here? Yes, the angle of refraction is greater. So when you compare the angles, so angle of incidence is less than angle of refraction. And the second one, let us compare the velocities v1 and v2 V1 is the velocity of light in the denser medium and V2 is the velocity of light in the rarer medium. Now which one will be greater here? So the velocity of light in the first medium, that is the denser medium, will be less than to the rarer medium, which is compared here. That is V1 is greater than V2. Next, when you compare to the third 3. Now again comparing to the wavelengths, as I have told you, velocity is directly proportional to lambda. So lambda is less than lambda 2. So the wavelength of the light which is present in the denser medium is less than to the wavelength of the light which is present in the rarer medium. And number 4 is the frequency. The frequency is constant when comparing both of it. So the frequency is constant. So in any kind of, that is whether it is traveling from rarer to denser or from denser to rarer, you need to observe that the frequency is constant. In refraction, the frequency is constant. That you need to remember here. So this is what we learned about the denser medium and rarer medium, and when light travels from one medium to another medium, it bends. So how does it bends? What are the cases? How will be their angles? That all we have seen over here. And the one thing you need to remember is the denser medium. So how does the denser medium, how can you compare the rarer medium is, remember that gases, liquids and solids. So a small thing there is, so when compared to the liquids, gases are the rarer medium and the liquids are denser medium. But when compared to the solids, liquids are rarer medium, solids are denser medium. So that means you can compare a little bit. So when they give two types of different mediums, so you need to understand which is the rarer medium, which is the denser medium. Simple. When there is a comparison of gases and liquids, gases are considered to be the rarer medium and liquids are considered to be the denser medium. Now when there is a comparison of liquids and solids, then liquids are considered to be the rarer medium and solids are considered to be the denser medium. When there is a comparison between gases and solids, gases are considered to be rarer medium and solids are considered to be the denser medium. And the rarest medium is said to be as the vacuum. So the vacuum is the rarest medium. That is, till now we told that air is the rarer medium, but when compared to the vacuum and air, vacuum is the rarer medium and air is all the denser medium here when compared to the vacuum. So vacuum is nothing but the empty space. So as there is no empty space over here, so vacuum is the rarest material. So as there is no mass, that is the empty space, no mass over here, so the mass is 0, so the density is 0 for the vacuum. But for air, we have some amount of gases in the atmosphere, that we have some masses. So when compared to vacuum, air is the denser medium and vacuum is the rarer medium over here. And one more thing that we will discuss about the refractive index. So we'll discuss about the refractive index now. So refractive index. So refractive index is the ratio of speed of light in vacuum to the speed of light in a medium. So this is the definition for the refractive index. That is, it is a ratio. So it is a ratio of the speed of light in vacuum, or what we call the free space, to the speed of light in a medium. So any medium which we are going to consider. So the refractive index is represented with the letter n, or sometimes most of them write it with the mu also. So both are also considered as the refractive index over here. So we have a formula for the refractive index, that is n is equals to C by V. So n equals to C by V. So where n is called as the refractive index and C is called the speed of light in vacuum and V is called the speed of light in the medium. So any medium which is going to be taken. Now C is said to be called as the speed of light in vacuum or free space. So we have the value that is C is equals to 3 into 10 to the power of 8 meters per second. So which is the speed of light in a free space or vacuum. So that is 3 into 10 to the power of 8 meters per second, and n is called the refractive index and v is called the speed of light in medium. So by using this refractive index value we can find out the speed of light in any of the medium. So what does the refractive index represent? So refractive index represents the ratio between the two mediums. That means it gives us information about which is the rarer medium and which is the denser medium. Number one thing. So the refractive index gives the information about the denser medium and rarer medium. It gives us the information about the denser medium and the rarer medium, number one. And number two, you can find out the speed of light in a medium. Speed of light in medium. So I think you understand what does the refractive index is. What it is, a speed of light. It is a ratio of speed of light in vacuum to the speed of light in medium. That's according to the definition, that's clear. So we have formula n equals to c by v, where c is the speed of light in free space, that is 3 into 10 to the power of 8 meters per second, and v is the velocity of in a particular medium. So what does the refractive index gives us the information? So it gives us the information about which medium is the denser medium and which medium is the rarer medium, number one. And number two is we can find out the speed of light in the medium over here. So we have a numerical that we will do a numerical here. So n equals to c by v. So what are the units over here? As it is a ratio of the speed of the light. So meters per second and here meters per second. So both get cancelled, so there is no other units left over here. So refractive index has no units. So the refractive index has no units, and the formula n equals to c by v is also called as the absolute refractive index. It is also called as the absolute refractive index over here. N equals to c by v. Now let's see the another refractive index, that is called the relative refractive index. So relative refractive index. So relative in the term means the comparison. The comparison over here, that is called the relative refractive index. So it defines as the ratio of refractive index of one medium to the refractive index of another medium. So it is the comparison of the refractive indexes of the two medium. So what are the two mediums we are having here? That is, for consider this medium as n1 and this medium as n2. Now if you compare the refractive index of the first medium and the second medium, that is what we call it as a relative refractive index. So we will be having a refractive index of the first medium, which is called as n1, and we will be having the refractive index of the second medium, which is called as n2, and the ratio of these two, that is the comparison, that is what we call it as the relative refractive index. So the relative refractive index is written as n21. It is now called as n21, not n21, it is n21, which can be written as n2 by n1, or otherwise n12, that is n1 by n2. Now what is the difference between these two here? That is, we have to call this as n21, which is the refractive index of the second medium with respect to the first medium. That is, we are comparing the refractive index of second with the first one. With the first one we are comparing it. We are comparing it with the first refractive index. So we have to write as n21, that is n2 by n1, refractive index of second medium to the refractive index of the first medium. That is, as we are comparing the n2 with the n1. Now for suppose you have taken the n1 and you need to compare its refractive index, comparing it with n2. When you are comparing it with n2, then you need to note it as n12, that is refractive index of first medium with respect to second medium, that is n1 divided by n2. For example, I have an example over here. So this is the surface and this is the normal n. This is the refractive index of a glass Ng, and this is the refractive index of water Nw. Now I need to find out the relative refractive index of glass with respect to the water. That means with respect of the water, I need to find out the refractive index of G with respect to water. Then how can we write it as N G W? That is refractive index of glass with respect to the refractive index of water, that is Ng by Nw. Or otherwise, I need to find out the refractive index of water when compared to the refractive index of the glass over here. With compared to the glass, I need to find out the refractive index of water. So that is Nwg, that is Nw by Ng. It can write like this also. So I think you got a clear understand about what is relative refractive index. Relative refractive index is comparing the refractive index of one medium with respect to the another medium. Now for example, if you want to find out the refractive index of N2, then you need to compare it with N1. If you want to find out the refractive index of N1, then you need to compare it with the N2 over here. So this is about the relative refractive index over here. So here we have another formula also, that is N2 by N1. N2 by N1 can also be written as V1 by V2, or also can be written as lambda 1 by lambda 2. That is the refractive index of second medium to the refractive index of first medium is equals to the velocity of first medium by the velocity of second medium. So how do we get this formula by the first one? As we have n equals to C by V. So as n equals to C by V, as the C is a constant value here. So if we remove the constant value, we get the proportion as n proportion to 1 by V. In mathematics, as we have a mathematics that is n proportional to 1 by V, then it can be written as A1 by A2 is equals to B2 by B1, like we have in a mathematics. So the same also here, n1 by n2 is equals to, as it is in the reciprocal, so we write it as V2 by V1. For example, if it is n2 by n1, then we can write it as V1 by V2, that is the reciprocal of it. The same thing that I have written over here, n2 by n1 is equals to V1 by V2, and as the velocity is directly proportional to lambda, so we can write it as lambda 1 by lambda 2 here. So remember this formula here, n2 by n1 is equals to v1 by v2, this as it will be useful in your solving the numerical part over here. So let us take an example of a numerical with n equals to C by V and as well as the relative refractive index. Let us take an example of a numerical. So let's take an example over here. So first let us find the refractive index for considering the speed of light in a medium. Speed of light in a medium. So let us consider the speed of light in a medium as v is equals to 2 into 10 to the power of 8 meters per second. So considering it as v equals to 2 into 10 to the power of 8 meters per second, and consider this as the first medium and this is the second medium, which is the rarer and the denser. Now we have to find out the speed of light of this second medium here. As this is the rarer medium, that is obviously that is the air, and this is considered to be as a glass. Let us take it as a glass. As it bends towards the normal, and we have to find out the refractive index of this particular denser medium. We have to find out the particular denser medium here. So as we know that we have formula n equals to C by V. So n equals to, we have the C, that is 3 into 10 to the power of 8 meters per second. So substitute that value, 3 into 10 to the power of 8 meters per second by the speed of light in a medium, that is given as 2 into 10 to the power of 8 meters per second. So 10 power of 8, 10 power of 8 is cancelled, and meter per second is cancelled. So n equals to 3 by 2, or it can be written as 1.5. So as the units are been cancelled over here, so there are no units over here, so 1.5. So 1.5 is the refractive index of the glass, that is 1.5, or it can be called as 3 by 2, which is the refractive index of the glass over here. So let's take another numerical example based upon the absolute refractive index. So this time the refractive index will be given, and we have to find out the refractive index of a we have to find out the velocity of a medium over here. So given that the refractive index n equals to 4 by 3, and we have to find out the velocity of light in that medium. So as we have a formula, n equals to c by v, that is n equals to, so as we have the n value, that is 4 by 3, so 4 by 3 is equals to c value 3 into 10 to the power of 8 meters per second by v. Cross multiply, then you will get as v is equals to 3 by 4 into 3 into 10 to the power of 8 meters per second. So v is equals to 9 by 4 into 10 to the power of 8 meters per second. So 9 by 4, you just calculate the value, so you will get as 2.25 something into 10 to the power of 8 meters per second. So this is the speed of the light, which we have the refractive index as 4 by 3, and this is the speed of light in water. This is the speed of light in water. That means the refractive index which we have, that is n equals to 4 by 3, is the refractive index of the water over here. Previous we have the refractive index of the glass, that is 3 by 2, and now we have the refractive index of water, that is 4 by 3. Now is it clear? Now, so this is another one type of numerical where they give the refractive index and we have to find out the velocity over here, and in some cases they will give out the velocity of light and we have to find out the refractive index over here. So for example, now let us compare. As I told you, the refractive index gives the information about the rarer medium and the denser medium, and also it gives us the information about the velocity of light, in which how much does it traverse, that we have find it out. Let us see that as we have the refractive index of glass, that is 3 by 2, it can be taken as 1.5, and we have the refractive index of water, that is 4 by 3, which is 1.33. Now when you compare these two, which has the greater refractive index? So which has the greater refractive index is said to be called as the denser medium, and which has the lower refractive index is said to be called as the rarer medium. Now is it clear about the denser medium, how to find out? Now for example, they have been given 4 types of different mediums over here. 4 types of different mediums, and they are given the refractive indexes as 1.5, 1.3, 1.01 and 2.41. Now in which medium is, among the 4 mediums, which medium is considered to be called as the denser medium? Yes, which one we have the greater refractive index? Greater refractive index is said to be called as the denser medium. Now among the 3, which one is considered to be called as the rarer medium? Yes, as C is having the low refractive index, it is said to be called as the rarer medium over here. So by this, with the help of the refractive index, we can find out that which one is the rarer medium and which one is the denser medium over here. Very simple. As before, just now we have find out the refractive index of the speed of light in a glass, that is 2.0 into 10 to the power of 8 meters per second, and the speed of light in water, that is 2.25 into 10 to the power of 8 meters per second. As compare the equations over here, the speed of light in the denser medium is less when compared to the speed of light in the water, that is the rarer medium, that is 2.25, so which is greater when compared to the denser medium. So by this you can easily find out that if as n proportional to 1 by v, that is if refractive index is greater, then the velocity will be less, and if the velocity is the refractive index is less, then the velocity will be greater. So the greater velocity, less refractive index, less velocity, greater refractive index, which represents for the denser medium, and greater velocity with less refractive index is said to be called as the rarer medium. Okay, so these are the points which will be useful for your competitive examinations. Now let's take another one more numerical based upon the relative refractive index. So the relative, we have the refractive index of glass, that is 3 by 2, and refractive index of water as 4 by 3. Now we need to find out the refractive index of glass with respect to water. It can be written as NGW or NGW. Here side also we can write it as, or you can write it as NGW. And also we have to find out the refractive index of water with respect to the glass, that is NWG. Now can you tell me the formula for the relative refractive index over here? So refractive index of glass with respect to water. So first we have glass, that is Ng by Nw. In this case, refractive index of water with respect to glass, that is Nw by Ng. So Ng we have the value as 3 by 2, and Nw we have 4 by 3. So 3 by 2 into, so this gets reciprocal. So when it gets reciprocal, we get 3 by 4. So 3 3s are 9 by 8. So the refractive index of glass with respect to water is 9 by 8. Now the refractive index of water with respect to glass is nothing but the reciprocal of this. So we get 8 by 9. So the refractive index of water with respect to glass is 8 by 9. This is how we have to find out the relative refractive index. So this is the numerical which we can find it over here. So right now, thank you for your time for watching. Subscribe the channel and wait for the more interesting videos. Right now, thank you for your time.